The Studio 5000 Logix Designer application allows us to create tags in which we may store data for use in our logic. The data type of a tag determines the size and format of the data it will store. Data types range from the simplest Boolean type to the most complex structures. However, even the most complex structures are ultimately made up of pieces from the 5 elementary or atomic data types. The 5 atomic data types are Boolean, short integer, integer, double integer, and real. To get a better idea of what may be contained within tags of the atomic data types, we can look to the Logix Designer help. So, in the top ribbon menu of our Logix Designer project, we expand Help and select Contents. From V31 on, Logix Designer Help is in HTML. Thus, the first time we open it, we will need to select a browser in which to view the help. For this example, we will select Google Chrome. To locate information on the atomic data types, we type data types in the search box and press Enter on the keyboard. When the search results appear, we can select data types. At the top of the page, we find a table that displays the contents and format of each of the 5 atomic data types. So, we see that a Boolean data type contains 1 bit of data. The 3 types of integers are all signed using 2's complement representation. The only difference between them is the range of data that they may store. The real data type is for floating point representation of decimal values. It should be noted that Logix 5000 controllers store data in blocks of 32 bits. So regardless of data type selected, every tag will consume at least 32 bits of controller memory. Let's close the help and create some tags to get a look at these data types in action. We double-click controller tags to open the table that contains all of our global variables. To add to the table, we need to select the Edit Tags tab at the bottom. Now we can create an example tag for each of the 5 atomic data types. Switching back to the Monitor Tags tab, we get a look at the values contained in the data types. Notice that we cannot write a value to one of the tags that falls outside of the range for the data type. Furthermore, we cannot write decimal values to one of the 3 integer data types. Of course, we may write decimals to the real data type. Note also that we may expand the integers to view their individual bits. The addressing for these bits is simply the name of the tag, followed by a decimal point and then the number of the bit starting at 0. In addition to the overall integer value, we may use these individual bits in our logic. In the Style column, we can choose how we want the values displayed. So, for example, if we were using the individual bits of an integer in our logic, we may choose to have that value displayed in binary rather than decimal.